if you don't know what you're doing. So let's talk about what we're doing with our exponents today. Because today, if you look at your worksheet, you notice that we have exponents raised to powers, and we also are going to be multiplying numbers and variables together that have exponents. Okay? So let's take a look at our first couple of examples here. Okay? The directions say multiply and write the product as one power. Okay? Let's take a look at number one. Number one says 6 to the 6th power times 6 to the 3rd power. Remember, you should be copying these down in your notes. Okay? Now, if we were to figure this out, we could actually write this out if you want to. Okay? We know that 6 to the 6th power would be like 6 times 6 times 6 times 6 times 6 times 6. Okay? Then we're going to be multiplying, and this is like, I guess this could be, you could say this is our first number. And then we're going to be multiplying that times 6 to the 3rd power, which would be like times 6 times 6 times 6. Okay? So if we were to actually figure that out, yes, that would be a huge number. We don't actually, it doesn't necessarily want us to figure that out today because it wants us to write the product as one power. Okay? So we're going to be writing our answer as a number with an exponent. Just like right here, which, yes, it gives you the answer to this one. It says it's 6 to the 9th power. But if we were to figure that out, look, count up how many 6s we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And we're multiplying all those together. So if we wanted to write that as a number to a power, all it would be is 6 to the 9th power. And to do that, all we really have to do is add up those exponents and keep the base the same. Okay? Well, no, there will be some that will be more difficult than this, yes. But to figure this out right here, that's all we have to do is add those exponents, and that gives us our correct answer. Okay? Now, this only works if your base is the same. If this number right here, if this was 6 to the 6th power times 5 to the 4th power, that wouldn't work because our bases are different. So if it wanted you to actually find your answer, you would actually have to multiply it all out to find your answer. Okay, but you could not write your product as one power in that instance. Okay, so let's take a look at our second example here. Number 2 it says n to the 5th power times n to the 7th power. Well, what do we have to do? Well, we have to add our exponents together. Okay, so this would be like n would be 5 plus 7. Well, what does 5 plus 7 equal? Yeah, so that would be like n to the 12th power. Now, we could write all that out if you wanted to, but I promise you're going to get the same thing. Okay? All right, questions on how we did any of those so far? Pretty simple, right? Yeah. Okay. Then let's take a look at our next couple of examples. Okay? The next screen is showing us what we're doing when we're dividing. Okay, because yes, we just talked about multiplying. Well, we also need to talk about dividing. Well, we also know that dividing and multiplying are opposites, so we can also assume that the way we do these is going to be the opposite. Well, when we're multiplying, we were adding. So what are we going to do when we divide? Well, we're going to subtract our exponents. Okay? Like up here on number 3. Remember, this fraction bar right here means a fraction bar means divide. Okay, that's all a fraction bar means. Okay, so I know. Oh, I guess they didn't really need to talk to me. So let's take a look at this. So we're going to have our 7 to the 5th power divided by 7 to the 3rd power, which is the same thing as saying 5 minus 3. Okay? Well, we know that 5 minus 3 is 2, therefore my answer has to be 7 to the 2nd power. And that's it. It's easy. Okay? Yes. Well, yeah, let's take a look. We know this one, again, we have to subtract because we're talking about division. So we're going to have our x, which would be to the 10 minus 9 power. Well, what is 10 minus 9? Yeah, so that would be like x to the 1th power, or yeah, it would just be, yeah, it could just be x, but I would prefer, I want to see it with the power, because that's what the directions tell you to do. It wants you to write it as a power. So, but that's what we would write, okay? Questions on our division? Again, it's not that difficult. Well, no, we still have one more we need to talk about. Okay, let's take a look at our next one. All right. The next one is talking about a base raised to a power raised to a power. I know. Blow your mind. Okay? No, really, what we're talking about, look, since we have this 5 to the 4th power right here in parentheses, okay, we're taking that 5 to the 4th power, and then we're raising that to the 2nd power. So really what that means is like 5 to the 4th power times 5 to the 4th power. That's really what that means. Okay, so if we wanted to solve that, that would be like, you know, 5 times 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 5. Okay, well, we can count all those up. We know that our base is 5, and we have 8 5, so that's going to be 5 to the 8th power. But an easier way to do that is to simply multiply my exponents here. Okay, 4 times 2. Well, that gives us our 8 right there. Okay? Now, remember, you multiply when you're dealing with a power raised to a power. Okay, remember the other way we add, but this way we are multiplying. So let's take a look at number 6. Okay, number 6, we're going to do the same thing. We're going to take our 7 and our 9, multiply those guys together. Okay, so my answer we know is going to be 6 to the 7 times 9 power. Yeah, so that would be like 6 to the 63rd power. Yeah, I don't want to figure that out either, right? Because I don't even, that would be terrible. Okay, but that's all there is to it. It's that simple. Okay, and I think that will, well, negatives are the same, okay, except with the exception, like, let's say, well, let's say like this 9 right there was negative. Well, if that was negative, then our answer over here would have been negative 63. Okay? But you don't have to do anything different today. You don't have to turn it into a fraction or anything else, because we're not really solving it. We're just writing our answer as a power. Okay? So we can still have a negative exponent. So your integer rules apply. So if the signs are the same, it'd be positive. Signs are different, it'd be negative when you multiply. Yes, sir? Yes. Yes, sir? Yeah, it's a number. You know, you can go to infinity just like every other number. Yeah, we're not going to do that, but yes, that is how it would be illustrated. Anyways, any other questions? No? Fantastic. Get to work. You should be able to finish in class, hopefully. Don't have any homework.